Let's let the tangent of theta equal 5/3 and the sine of theta less than 0. And then you're going to be asked, given some sort of information, you're often asked to find another trig function of that same angle in the given information. So given that the tangent of theta is 5/3 and the sine of theta is less than 0, can you find the cosine of theta? We actually did a problem similar to this the other day in the first quadrant. Remember, we used a helper triangle? I want you to use a helper triangle again, except you have to, in these examples, determine which quadrant to draw that helper triangle in. So here's the x-axis, here's the y-axis. Look at this gives us some useful information. Tangent of theta is equal to 5/3. Is 5/3 bigger than or less than 0? So the sine of the tangent is positive. The sine SIGN of the tangent is positive. But the sine of the sine function is negative. So which quadrant do we have to be in? Quadrant 3. If you go back and look at our memory device, all students take calculus. We can't be in the first quadrant because even though tangent's positive, the sine is negative. No way can we be in the first quadrant. Does everybody see that? The only other option where the tangent's positive is the third quadrant. So that's one way this memory device comes in useful. You can immediately determine which quadrant you're in. We must be in quadrant 3, Q3. Okay, that's what both bits of information give us as far as which quadrant theta is in. Does that make sense? Okay, so draw your triangle in quadrant 3. Draw your helper triangle in quadrant 3. So theta looks like this. That angle right there is theta. And then your triangle will look like this. You draw your ray, and it really doesn't matter how long you draw your ray. Just pick any point along this ray that you've drawn for your terminal side of theta and raise a perpendicular, and then focus on that triangle that's created. The size of the triangle doesn't matter because the trig functions are all based on ratios. And no matter which point you pick to draw your triangle at, so if you, let's say you pick this one, and this big triangle here is what you were focusing on, yeah, those triangles aren't the same size, but they are similar, and so the trig functions will be the same because they're based on ratios. Okay. So focus on the original triangle that I drew. And okay, now use the fact that the tangent of theta, TOA, the TOA part of SOHCAHTOA, use that fact to tell me how to label two of the sides of this triangle. What would the opposite side be? 5, right? TOA, tangent equals opposite over adjacent. So what would the adjacent side be? 3. Can we get the hypotenuse then? Yeah. What's R? R stands for the hypotenuse. R squared is equal to 5 squared plus 3 squared. Be careful not to call it 4, right? If it's going to be a 3, 4, 5 triangle, the two shorter sides have to be 3 and 4. One of them has to be 3, one of the others has to be 4. If the hypotenuse, if one of the, let me put it this way, if one of the shorter sides is 5, then you don't have a 3, 4, 5 triangle. All right, so what do you get for R squared? Yeah, 25 plus 9 is 34, so R is root 34. And by the way, R is always positive, okay? R is, we consider the length of the hypotenuse a radius, and so it's always positive. So in this triangle, root 34 is the length of the hypotenuse. Okay, so we want to find the cosine of theta. So let's think about the ka part of SOHCAHTOA. Cosine of theta, looking at this triangle outlined in green, what does the cosine of theta say? Yeah, cosine is adjacent over hypotenuse. What's the adjacent side? 3. The hypotenuse is root 34. There it is. That's it.